All right, everybody, hello and welcome to our first topic in the course, which is the scientific understanding of behavior. So I think this is an important place to start because before we get into the nitty-gritty of the class and all the specific types of research methods we'll be talking about, there are some foundations or ideas that will underlie everything else we talk about in the course. So let's go ahead and get into it. The scientific understanding of behavior. So remember that psychology is a science and we follow the rules of science. So we'll be talking about the scientific method here, but we'll also be talking about just general rules of good science. How do we do science well, and what do we need to think about when we're addressing research, whether we're reading research or we're conducting research. So I always get on my soapbox with this class. Even if you're not interested in going into research yourself, research is all around us. There's market research, people trying to get you to buy things. There's scientific research, research on big pharma, pharmacology, medications and so on. It's all around us and people will use it to manipulate you. So the stronger you are in understanding research methods and statistics and how they all work together, the better consumer of information you'll be. And this is in your personal life as well as in your professional life. So we use a lot of skills in this class that translate really well to other fields. We're talking specifically about research methods in psychology, which poses its fair share of difficulty. But research methods are consistent across all fields. And that's why we have the scientific method that spans across multiple fields. So as we're talking about these things, we'll focus on the challenges of psychology because we're all in psychology. But it's not to say that these methods don't have a place elsewhere in science. So why do we conduct research? All right, why do we conduct research? It's a good question. What's the point? We will be conducting our own research in this class, and you're going to get a taste of the process. So research, it's not an easy process. It's not terribly hard either. But why do we do it if it's so much trouble? Why do we go through all this trouble? And the answer is it's to answer questions, to answer questions that we think we deserve answers to. For every question, we can develop a research model. So a research model is how we plan to answer that specific question, and some answers are easier than others. So maybe I have a research question about how many students in my class are socially satisfied. Are we meeting our social needs, friendship and so on? If I'm interested in people in my class, I can ask them some questions and I can answer that question for myself. And that's a simple question. Some questions are not so simple. So I have a few questions I pose here. Why are we attracted to some people and not others? Okay, interesting. A social psychology question. Attraction is a vast subject in its own right. Maybe we know why people are attracted to each other, but maybe we don't. We've maybe heard that opposites attract. We know that's not so true for long-term relationships. But attraction and our social psychology and how we interact with other people, it's a question that we still don't completely understand, although we understand it in some facets of it. Another question, why do we dream? People love to talk about dreams. You're going to do a research project in this class and maybe you want to ask people about their dreams. But I'll tell you this right now, we don't understand dreams hardly at all, even with researchers working on it constantly. I mean, dreams have been in question since the very beginning of psychology and earlier in philosophy. Freud, for instance, was very heavy on the idea of dreams being significant to our psychological processes. But the simple question of why do we dream, we don't have an answer to that. We don't know. Another question, what causes depression and what can we do to alleviate it? It's a very practical question in psychology, and many of you might want to go on to be counselors or psychologists or psychiatrists. And this type of research that informs psychological disorders like depression will be part of your career. Can we improve our memory? And if so, how? We'll talk about memory a lot this semester. Our memory is bad, if you're not already aware. Some, like my own, are worse than others. The human memory is very faulty. Our short-term memory can't hold very much. Our long-term memories are largely unreliable. So this is not to give you an existential crisis, but to make you think about how would we go about measuring something that's so difficult to measure? Can we improve our memory is another great question. You'll see gimmicks, you'll see vitamins that say they'll improve your memory, you'll see apps and phone games that say they'll improve your memory. But to really answer this scientifically is complicated. It's not entirely clear how you answer it. How about what makes us aggressive? And can we do anything to make us less aggressive? That's another great question that has social implications as well. We live in a violent society to some degree. If we can understand the mechanisms underlying aggression, we might be able to alleviate or prevent aggressive acts in the future. And while we're talking about all of these questions, we can think about the interdisciplinary nature of these ideas just within psychology. We know that there are neural mechanisms or biological mechanisms that underlie aggression as well as our dreams. So we can start to think about how these questions are multidimensional and how there are research models we can use to address really any of these questions. And so that's why we do research, to answer interesting questions or to solve problems. Okay, you've got a question, let's figure out an answer. That's research. But what is research? Research is basically just a report of information. It's the who, what, where, when, and why of the situation. You've maybe heard this before for other types of writing, and it does apply here for science as well. When we publish a piece of scientific work, we want to know who wrote it, what's it about, when it happened, like the year it was published, or the year the research was done, where, who published it, why, what was their motivation for publishing it. We live in the information age, and with the internet we have many different platforms that publish information. So when I say publish here, I'm not talking about publish on the internet or on a website. We're talking for research specifically published in a scientific journal. So I have a scientific journal over here. It's called Science. This is one of the biggest scientific journals there are. It's a very well-respected journal. So to get your article in there, if you write up a research report, say you do some fascinating research on why we dream, let's say you're a cutting-edge dream researcher and you write up a research report, you collect some data, and you want to make a statement about dreams, you would need to have it peer-reviewed in order to get it into a scientific journal, especially a quality one. And what is peer review? It means that the peers in your field, people on the same level as you, review it anonymously to see if your science is good, to see if you follow the rules of the scientific method, and to see if your claim seems to be reasonable. And we'll talk all about reasons why a claim or a study might not be good or why it might be good. We'll talk about all sorts of topics like reliability, validity of studies, our sampling methods, how do we get the individuals that we're using for our study. So scientific research, or the research we'll be talking about in this class, is something very specific. It's published in a scientific journal and it's peer-reviewed. All of the research we will read in this class will be published and peer-reviewed, unless we're having a discussion about some bad science, in which case it might come from somewhere else. But this is what we're talking about. We're going to learn how to use databases to find this type of research, to find research that's been peer-reviewed by other professionals in the field. So we'll keep this in mind, okay? This will inform us for the rest of the course here. Real science is peer-reviewed, published in a peer-reviewed journal article. Okay, so why does research matter? Why do we do it? We're talking about why we do what we do, to answer questions, which can be interesting. But sometimes we're answering questions that don't have a lot of public or social impact, maybe not even interesting. Maybe I want to do a study on how cute my dog is. I could do that study, but does it matter to anyone but me? No, it doesn't. However, there's lots of research that applies to many, many people. So I have an example here, parental opinion about vaccine safety. So this is really relevant, right? This is from an older study. This is from, I believe, around 2015. Vaccines are always a hot topic now, and we're currently sitting in, we just got out of COVID, so it's like an extra hot topic, right? But why does research matter? Because public policy can change due to research findings. We have the FDA, we have the NIH, the National Institute of Health, the Food and Drug Administration, the FDA. They inform policy and policy changes, okay? They decide policy changes that will hit our social sphere. And we have the same impact with psychological research. So how do we treat those who are suffering from mental illness, for example? That eventually gets to our government. We have issues in the prison industrial complex, which deal with those who are mentally ill. So we need research, we need information on these topics to make well-informed decisions about them. Research can be used in court cases. It's used for the law. We'll talk a bit about that throughout the course. And then most importantly, information forms opinions, or lack of information informs opinions. So we do our best with the information that we have. We're concerned with the who, what, where, when, and why, where it's coming from. Do we trust that information? But again, the important thing here is that research ultimately has a larger impact than you might think. A single paper might not do much to our social structure, but if we have a repetition of findings or results, we find the same thing over and over again, that might ultimately go on to change public opinion about any given topic. So I do have an image here about transparent opinion on vaccine safety compared to 1 year ago, okay? And if you're not up to date on the vaccine debate, vaccines were really debated in terms of safety within the last decade or so, and were attributed to rising autism spectrum diagnoses, among other things. So we're interested in knowing how people feel about them because they're a public safety concern in and of themselves, people's feelings. So here, compared to what I thought a year ago, I think vaccines are safer, about the same, or less safe, okay? Yes, okay, safer, about the same, less safe. So we can see general trends in the data to see what people think. And of course, this is a product of who we're asking, and we're going to get all of that throughout the semester. We're going to talk about all of that here, okay? All right, different types of research. We're going to talk about all of these in great depth later, but it's helpful to get used to sort of the language as we're talking about research. And you should have had at least a quick overview of these in your statistics course, so we'll be reviewing them here. So we have observational research, or what we call descriptive research. This is research that we do not intervene with. Think of it as watching kids play on the playground and marking how many aggressive behaviors they show. We're not putting them in a situation, asking them to do anything specific. We're not manipulating anything, adding in, say, maybe an aggressive child and see how they're reacting. We're completely hands-off. We're observing and we're describing. We're just observing and describing, nothing else. Correlational research looks at the relationships between two things. So we're not directly intervening here either, but we are selecting which variables to compare to each other. And then we have experimental research, right, where we do meddle or manipulate different pieces of the study. And experiments are so important because they can attribute cause. They're causal, or at least we hope they are. We're going to talk about the word cause a lot because cause is a word that we have to dance around a little bit in science. People will say that one thing causes another when what they really mean is that one thing is related to another. Again, much more on this as we go, but it's good to get used to this language out the gate, okay? It'll be easier later on. So variables, right? Independent and dependent. Some other language we want to get used to. This is our intro to independent and dependent variables. You'll be coming up with your own independent and dependent variables in this class. Psychology variables, we'll talk all about them. But independent and dependent variables are crucial to any type of experimental design or to any type of study. And you've maybe heard definitions for these before, and they can often be a little bit confusing. I think that the language used to describe these it can be challenging. So we're going to start very, very simple, hopefully in a way that you can really easily understand. So the independent variable is a predicting variable. It's a predictor. We think that it's predicting something else, and that something else is the dependent variable or the outcome. So I have an example over here, okay, watering a plant, giving a plant fertilizer. Those would be independent variables or predictors. We might predict that giving a plant water and fertilizer would ultimately result in the outcome of more plant growth. So predictors and outcomes, independent and dependent. Because you've maybe heard the word manipulate, the independent variable is something that we manipulate. And in that case, we see in this diagram that we can manipulate how much water we give a plant, how much fertilizer. But we'll get into this later with correlation or regression. Maybe you think that gender predicts anxiety symptoms. Well, we can't manipulate somebody's gender for our research purposes. That would be 1, difficult, and 2, unethical. But I like this verbiage here, okay? I like this language. The independent variables are predictors, and dependent variables are outcomes. So gender predicts, anxiety, the outcome of anxiety. So if you start to think of them this way, it should make research situations clearer as we go, okay? Just keep referencing back to this if you need to. All right, causality, understanding causation. And then a little bit more on cause, okay? Causality. Another major building block of research, because what we're going to start doing is being very careful with the word cause. If you hear the word cause, if you read about it in a news article, that one thing causes another, you should raise an eyebrow. You should be skeptical, which is something else we'll talk about here in a minute, okay? But cause is something specific. It means that the independent variable caused the dependent variable, and nothing else contributed to that. And what we'll come to find is that in science, it's very hard to do. It's very hard to look at things in a vacuum in that simplistic way. We often have what we call confounding variables, okay? A third variable, which wholly or partially account for the relationship between the other two, okay? the other two variables. And these are problematic in all types of research, not just psychology. We can never completely rid ourselves of confounded variables. And then I just have the word error here, which looks like an error in itself. It's just floating over here. But error is all around us as well. If you remember in statistics, we often calculate for error or standard error. So when we take our standard deviation and divide by some function of our sample size, because that's what we're basically admitting, is that we have a sample, but it's not everybody that we're interested in measuring. So our sample is not perfect. Therefore, the statistics we get are not perfect, and we have some error. So when we say that one thing causes another, we have to be very, very careful, and we have to be pretty certain of it as well. Not totally, but pretty certain. It's something that we want to see time and time again. So we're going to get more comfortable with using words like relationship. There's a relationship between two things, because then we could go on to explain that relationship. But saying that one thing causes another is a very strong statement, and it's not as likely as you think that we truly unearth the cause and effect of two things. Take something as complicated as depression. What causes depression? We could probably make a long list right now of things that contribute to depression and have a relationship with depression, but it would be difficult for us to say what causes it. So that's causality. We'll be careful with that word. If we want to say that something causes another, we have to have a randomized experiment, a randomized assignment. And we'll talk a lot about this when we get to experimental design. But we need something that looks like this. We need a control group and an experimental group. If we're doing experimental research design, the experimental group will receive something the control group does not. Let's stick with depression. Okay. Let's say that we are testing a new depression medication. Okay, so we would take a group of participants, people with depression, we would randomly assign them, that's the word random assignment, we would randomly assign them to one of two groups, either a control group or a baseline, or those that maybe will not receive a depression medication and the experimental group will receive the medication, and then we'll compare the groups to see if there are any differences. If the experimental group, which receives the pill, sees a reduction in depression symptoms, we might be able to say that that pill caused a reduction in depression symptoms because we have something to compare it to. When we do something like a correlation, though, we don't have that. We don't have a baseline or a group. We don't have the control group that we can point to and say, hey, we've seen a marked change from this other group. And that's just our basic overview here. But we want to be careful with cause, okay? That's the main piece here. Be careful with cause. Okay, correlation does not imply causation. And let's talk about it some more, okay? You've maybe heard this phrase as well, correlation does not imply causation. Hopefully your Psych 101 teacher taught you that, meaning that if two things are related, it doesn't matter that one caused the other. So, so here we have, I like to do this on all my classes, share what we call spurious correlations, or relationships that exist that we can't necessarily explain. So in this case, we have rock music quality versus U.S. oil production. Without having much understanding of how to interpret a graph like this, we can at least see that the trends of the two seem to be similar. So it would be ridiculous to say that the quality of rock music caused an increase in oil production or vice versa, right? So it's funny to look at this and say, haha, so silly. But it's not so silly when it's a real issue or some real variables being used, okay? This is another one for laughs a little bit. Not that murder is funny, but Internet Explorer use versus murder rates. We see a trend here, or a relationship between the two variables, but it doesn't mean that the downfall of Internet Explorer also caused a decrease in the murder rate. And in fact, there's a pretty interesting idea behind this sort of trend, because murder rates have plummeted over recent years, and it's thought to be because of the internet, because of intelligent systems that make it more difficult to carry out such crime, at least in part. So we can explain this a little bit, but it seems a little funny or ridiculous to compare it to Internet Explorer specifically, okay? Even though it looks like there's a relationship, you know, as far as we know, there's really not. But then we have something that's not so funny or not so ridiculous, okay? We have a correlation here that is implying a relationship between autism diagnoses and organic food sales, okay? My background is a little bit in autism. I've done research on autism spectrum disorders using neuroimaging. Autism is, of course, complex. We don't know the cause of autism. Some people might say they do, but science as a whole does not agree that we know the cause of autism, okay? So what does a graph like this mean? What we have here is a very strong correlation. If you remember correlations from statistics, correlations can range from -1 to 0 to +1. The closer you are to -1 or +1, the stronger the correlation. The closer to 0, the weaker the correlation. This is a correlation of almost 0.99, almost a perfect correlation, meaning that there's a very strong positive relationship between these two things, autism diagnoses and organic food sales. As one goes up, the other's going up. So if a scientist looks at this, they would say, interesting, and give it some thought. Think about, why does this relationship exist? The problem here is that this made it into the public sphere. People in the general public saw this graph, saw this information, and said organic foods are causing autism. There was an outcry that organic foods, how organic foods are being treated, was leading to more autism diagnoses. And a group of people grabbed onto this and ran with it. And we can't blame those that they're not scientifically literate for doing something like that. People want answers to their questions. And that's why we do research in the first place. But as a scientist looking at this, and the scientist that you're all becoming by taking a class like this, you should look at this and be skeptical. You should say, okay, a relationship is here, for sure, but maybe there's a confounding variable or something else that's contributing to this relationship. And what is contributing to this relationship is time, okay? It's right here on the graph. Organic foods have become more available in recent years. Of course, this is an older study from, I believe, 2010, 2011 maybe. Organic foods have become more available and autism diagnoses have been rising. And of course, people with kids with autism want to feed them organic foods. So maybe that's why, maybe that's the connection. But again, we don't know why. We can't say the cause and effect because but we have some ideas, but we can't say, okay? The ideas being that autism diagnosing is more widely available through schools and other programs. Anyhow, we can't point fingers at others. It's why vaccines and autism have been a hot topic. But, we can look at funny examples like this, weird examples, and some examples that are really alarming. I mean, beyond this, people misuse statistics all the time, purposely and on accident. People might create a correlation between gender and autism. We can't correlate a categorical variable like gender. We have to have a certain type of data. And we'll be reviewing types of data in a future topic. Okay, don't let this confuse you too much. So anyhow, correlation does not imply causation. Even if you've heard that before, we're going to start to think about it more and more. We're going to start to really think about what this means and how we should be thinking about it in the research that we read. Okay? Scientific language, okay, and skepticism. So in addition to being careful with the word cause, we're also going to be careful with some other words, things like prove or the truth. We rarely prove anything in science. We rarely unearth the truth. But what we do is we accumulate evidence to suggest something. And once we have enough evidence to suggest something, that's when we start to hold something as probably true. That's the best science will ever say. And we'll even use that word lightly because what we're basically saying is that it's true for now, or it's our best understanding right now, or it's what we have evidence for right now. And we know that it can change with more research. We have to stay humble in science. So we'll talk a lot about this, but we have a lot to talk about. This is our very first topic here, but we want to be careful with language. We don't prove anything. We don't find the truth. We talk in a very specific and deliberate way, much like how you learn in statistics, hopefully, where we either support, we retain, or we reject the null hypothesis, but we never accept it. We never accept the alternative or research hypothesis. We're just accumulating evidence. That's what we're doing, accumulating evidence. So I really like this comic. I think it's great because it's about cause. It's about cause and attributing our information as the truth when it might not be. The last thing I'll leave us with here is just about skepticism. And skepticism feels sort of like a bad word, like it's bad to be a skeptical person, but it is not. I assure you it is not. I like to use the term healthy skeptic. Be a healthy skeptic. When you're faced with some research, you should think about the who, what, where, when, and why. Where did this come from? What are they trying to get from it? When was it published? Is it recent? Is it old? You should meet claims with skepticism. You should ask yourself as well, when you hear a claim, you should ask yourself, how would I have answered the same question? And that's what this class is all about. It's about our research methods. What method might you have used to address that question? And then look for repetition and consistency. So we'll be talking about the scientific method in this class, And the scientific method, it's not a set of steps that you do and when you're done, it's a set of steps that, and that's it. It's a set of steps that when you get to the end, you start right back at the beginning. It's a cycle. And we're looking for consistency, repetition, doing experiments over and over again in various different ways. And that all puts some weight into our claims, okay? Okay, so anyhow, we made it through the first lecture. Very good. So as always, just be in touch if you have any questions on this material. And I will see you over in the next one. All right? Bye.